Dear students, welcome to the online session of Electronic Devices and Instrumentation Laboratory session. For the laboratory, in today's session, we will be covering on various components we will be using throughout our laboratory for the current semester. And we will see the introduction, then how the use of this instrumentation and what are the architecture of this. The very much basic component, the most used for the device, that is the electronic device, will be a breadboard. Okay, I hope you can see the diagram in front of you. It will be looking like dotted holes. Okay, we'll see the first diagram in which I have marked with a red colored. Okay, here plus. Okay, I hope you can see this is a plus. Okay, when we are making a connection for any of the circuit, okay, you consider that the full line, whatever it is marked with a line, it is a continuous line. Okay, there is a connectivity for each hole, each dotted hole, in which you are inserting a electronic component. Okay. For example, if I inserted the point here, okay, the same connection is available at the second point of the hole. Similarly, it is available at the third line, okay, fourth line. Likewise, means you consider that, okay, this is a full line, okay, sorry, there's a full line, okay, whatever it is marked, having a same connection. Means the connectivity available when you insert a component at any one point in the below dotted hole, all the line below line will be having a same connectivity line. Okay, you can tap an instrumentation you can tap an instrument from the corresponding dot. Okay, now I hope I shown with like a line below this, means it's a continuous line will be available for the below line. Okay, now there is a breakage. Okay, at this point there is a breakage, means there is no connection between this point and this point. Okay, there is a discontinuity. Okay, again you consider that this is a separate line. Okay, means if I make a connection like this, okay, below line, all the line having a same connection. Okay, now if I say this will be like a different connection, different connectivity. Okay, there is a separation line. Okay, I hope you can see just above the line, just above there is again one more dot. Okay, it is made up of like a rows. Okay, the first row, whatever is that, okay, it is also having a connectivity same way. Okay, like this. Okay, there is the same connectivity. Okay, there is a separation between these dots. Okay, both are not interconnected. Okay, the first row and the second row are not interconnected. Okay, all the first row are connected. Okay, you consider that like this. Okay, there is a first row. Okay, up till this one. Okay, sorry, the first row, whatever it is that I have mentioned. Okay, has a connectivity. Okay, there is no connectivity between the first row and the second row. The second row it is connected up to the discontinuity line. Okay, I hope you understood this one. Okay, now this is what the connectivity for the breadboard. Okay, now let us come to the below line. Okay, you can say it is this line, these lines. Okay, there is a connectivity for each dotted line here in vertical way. In the above, whatever the first row, okay, and the second row, there the connectivity in the horizontal way. Okay, in the second, in the below line, whatever I shown with like the mark here with a circle, the connectivity in the vertical way. Okay, means the line okay, these lines are connected. Okay, it means interconnected. Okay, means there is the same connection is available at this line. It is a column line. Okay, second column is a different connectivity. Okay, there is no connectivity between first column and the second column here. Okay, the third column is nowhere connecting between the first second. Okay, so likewise when I consider these points here, okay, it is in the column way connectivity. Okay, similarly, okay, you can see this is a one more connectivity line. Okay, the same whatever I have shown here in the top. Okay, it is also in the form of like a vertical connectivity. Means if you inserted any one component, okay, here, okay, for example, if I insert, I'll show anyway. I'll make the point for you. If I inserted a point here, okay, at this point, okay, means full line having a same connection. Okay, you'll get if the same line is from this one, you can tap most of the components, provided depends on the circuit diagram. Okay, I hope you understood this one. Okay, the very top horizontal, the below this one is a vertical connections. Okay, below this also is a vertical connection. Whatever, okay, in the bottom line, okay, in bottom this one, okay, it is also same as the first one. Means how it is? Okay, it is a horizontal connection. Okay, there is a disconnectivity here. Okay, there is a disconnection between this row, and this row. Hope you understood this one. Okay, there is a line connectivity. Okay, for each breadboard. Okay, this is why we call as a breadboard is a connectivity board also, because the basic components what we use for the electronic circuits are resistor, capacitor, inductor. Okay, now depends on the circuit diagram. Okay, each will be having a two arms. We will be inserting it. Okay, we will insert depends on like how the layout diagram what you have drawn on the paper, and the same connection we are trying to replicate on the board. Is the physical existence of the connections. Okay, now I think you might have seen this integrated circuits. The integrated circuits, it is look like a rectangle. Okay, the rectangle one, okay, it has got like a legs. Okay, let us assume that my integrated circuit having 14 legs. Okay, 7 one side, and the exactly opposite side we are having a 7. Okay, when we try to insert, okay, we will be inserting at this position like this. Means each has got like a legs. The legs will be inserted at the point, and from this one, okay, if I inserted the IC integrated circuit here, the connection is you can tap it from each column. Each column you can tap and you can retrieve, you can access the connection for the other components. Okay, I hope you understood this one. Okay, we call it as a breadboard, and anyway it is also available. Okay, some of you might have used also. Okay, it is available in the market. It is in the very reasonable rate. Okay, if you are interested for like any kind of like a circuit connection by working on yourself, you can have it for your own. Okay. Okay. Now this is in the right side I shown. Okay, the same breadboard in vertical way. Okay. However, how you want, you can place it and you can have a connection here. I hope you understood the basic breadboard operations, how we can use it for the connection purpose. Okay, this is what, okay, I have shown with the colored mark with a green. I hope you can see, okay, the green colored total mark. Okay, there is a connection will be there in the horizontal way, in the vertical way. Okay, in the first row, okay, there is a horizontal connections. Okay, in the below this one it is a vertical connections. Below this also there is a vertical connection, and in the below of operations there is a horizontal connection. Okay, in the right side you can see this is a circuitry. Okay, inside when you open it, okay, when you open from the top, okay, there's a case from the breadboard. Internally you can see the coil will be connected, the line by line. Okay, sometimes you can when you there is like a small pin will be available. When you open it up, you can see you can see there is a connection, how the connection will be made. Okay, there is the internal architecture, how it is made. Okay, now I hope in the right side you can see very clear picture here. Okay, the connection is available here. Okay, there is a LED will be connected in the vertical way, verticals. Okay, now I hope you can see there is a separate connection here. Okay, there is a gap will be available. Okay, and this will be a connector. No columns are connected. No columns are connected. Okay, there is a each column. I say this will be now in this diagram. I can say it is in the row way because I made it in a vertical fashion to look. Okay, so yeah, I say it will be like in this. Okay, this is how it is shown. The layout is shown in the horizontal. I call it as a column. Now the same one I kept it in a vertical way, and I am going to be showing its internal architecture. I can say this is a row wise. Okay, row wise and the column wise. Okay, I hope the physical the architecture is very much clear for you. Okay. This is how the connection can be made by using a breadboard. Okay, and in the just now I just conveyed the message for you how we can insert an integrated circuit so that I can make a connection. Okay. Look at this one. I inserted the integrated circuit. We call it the IC, integrated circuit here. Okay, it has got like a legs. Okay, there is a 3 integrated circuit I am using. Okay, and depends on like a circuit requirement. Okay, there is an electronic circuit requirement. It is a capacitor, or it is a resistor, inductor, or a crystal oscillator. Each will be having arms. Okay, by using the arm, we will be inserting in the breadboard, and we will try to replicate in the form of like a physical connection. Okay. The most used. Okay, there is a very much essential point for the circuit diagram is your VCC and the ground, because most of the component, okay, has to go to the ground. Okay, so that there is a convenient way is used that the top row, okay, there is a above row will be used for the ground connection. Okay, and the below one you can use the VC, vice versa. It is not compulsory. It is not mandatory that you can use it like this. Okay, because most of the components will be going, okay, to the ground. Okay, and most of the VCC will be connected to the many components. Okay, so that you can't find it in the vertical fashion. Okay, so that it is left to the circuitry diagram. Okay, how you made, and you can use it here. Okay, right. Now, in the coming slide, we will be seeing, we'll see with basic electronic components are resistor, capacitor, and inductor. Okay, how it looks. Okay, these are very basic components, so I am telling you, because further you are going to be study about diode, transistor, and SCR, crystal oscillator. Many will come. Okay, but very much essential component. I am just today in today's class I am going to be covering up with the essential components. Okay, are resistor, okay, capacitor, and inductor. Okay, I hope you can see. Okay, in the most of the components, they are having a 2 legs or legs. Okay, now these are the legs will be getting inserted into the breadboard. Very okay, the first one, what you can see, there is a resistor. Okay, resistor. Okay, we are in the market. There are the different value resistor will be available. Okay, these are the fixed resistor. Fixed means the value of the resistor won't change. Okay, it's a fixed value resistor. Okay, definitely there are in the market there are 1 kilo ohm. Okay, I hope you might have know the unit of resistor is a ohm. Okay, in the market there is like a different resistors are available with 1000 ohm, 1k. I say 1k. Okay, 1.2k means 1200 ohm. Okay, 1.5k. Okay, there is no resistor will be available with 1300, 1400 odd. No, not like this. Okay, like 700, 800, 500 ohm. Okay, yes, available. Okay, 1000. Okay, and very if I say you may have a question that if it is not available 700 in my circuit, if I want to use it, okay, the tolerance is acceptable. Okay, the plus or minus tolerance is acceptable for the resistor components. Okay, let us check that according to your design you got something like a 700 ohm. Okay, but in the market 700 ohm, if you go and search for the 700 ohm, it may not be available. So what you can say, nearby value 1000 ohm. Okay, 1000 ohm resistor can be used. Okay, that is slowly how when you are designing and when you are making a connection, okay, you come to know, okay, how the requirement, what are the requirement, and how do I make it so that my circuit has to be work. Okay, you don't say that there is an error from the circuit diagrams or from the output. No, okay, because the tolerance is accepted from that resistor. It is straight away given. Okay, for the tolerance for all, there's a capacitor or the inductor, the tolerance is accepted. There's a plus or minus is accepted here. Okay, anyway, okay, you might in the sometime when you visit the laboratory, you may see there is a decayed resistance box. Okay, its value you can vary. Okay, you can vary and you can have any resistor, 500 ohm, 200 ohm, but provided when you look, when you physically look into the, okay, when in the laboratory, the size of the box is quite big. Okay, and if your circuit diagram, okay, if you require like thousands kind of resistors, and if you brought those kind of big boxes and then try to make a connection, okay, as good as you require more than half of the room of a laboratory, okay, for the small circuit diagram. Okay, so that's why like as the resistors are tolerance are accepted and you can have a correction. Okay, the next component, okay, the just adjacent to this, we call them as a capacitor. Okay, there's various capacitors are available: ceramic capacitor and electrolyte capacitor. Okay, ceramic capacitor, I hope you can see with a it will be look like a flat. Okay, the ceramic capacitor. Electrolyte capacitor, okay, what it is mentioned with like a cap, okay, inserted with a cap here, okay, like this one, okay, electrolyte capacitor, okay, in which it has got like a plus and minus. I hope you know that capacitor symbols. Okay, and capacitor symbol will be given like this, okay, plus minus, okay, so that you can have a connection here. Okay, there is no plus minus connection for like a resistor. I hope you know the symbol of resistor also. Okay, this is the symbol of resistor. Okay, what is the symbol of inductance? Okay, you like this symbol. Okay, okay, these are the capacitors you can see. Okay, and what is the unit of capacitor? I say is a farad. Okay, and different types of different value capacitors are available. It is a microfarad, picofarad, okay, and more than that, nanofarad capacitors will be available. Okay, don't come and ask us that there is a 1 farad. Okay, there is a 1000 farad. Okay, no, not like this. Okay, the value of capacitor has to be minimum. Okay, it is measured in terms of like F. We call it as F farad. Okay. Now there is the next component is inductance. Okay, I think I shown with like only one component of inductance. Okay, there's a many components are available. Okay, just I'll make a one just simple operation for you. Take a coil, take any wire. Okay, just take a wire. Okay, you make it in like a spring way connection. Okay, like this, whatever I shown. Okay, twist it, it becomes a inductance. Inductance is nothing but a storage device. Capacitor is also storage device. Okay, just you make a you make in terms of like a coil, it becomes an inductance. Okay, Now that's like it is a the fixed value inductance. What I show is a inductance. What is the unit of inductance? Is nothing but a okay. Okay, unit of inductance is Henry. Okay, now we have different inductance, millihenry. Okay, and we have a 1 Henry also inductance. You can use it for the purpose of operation. Okay, this is what inductance is look like. Okay, and also in the laboratory you can see there's a box kind of like a inductance is available. Okay. There's no plus and minus is okay made for the inductance. Okay, depends on the current flow, the charges will be getting stored and you will be using it for the purpose of operations. Right. Okay. Now in today's session, okay, there is no. I'll be basically I covered with the 3 components: resistor, capacitor, and inductance. Okay. Now I told that you need to be measure its values. Okay. When you want to measure the values, okay, the capacitor and inductance for the measurement purpose, we are having a big instrument. Okay, it's a big instrument is available to measure its values. Okay. Now similarly, there is no instrument will be available. It is available. Okay, it is available. Okay, to measure the resistance also, but by physical observation also you can straight away tell the value of a resistor. Okay, then how it is possible? There is some kind of like there is a systematic approach has been given to by looking onto its color coding. Okay, the color coding is mentioned. Okay, on the body of the like a resistor. Okay, by using that color coding, you can calculate the resistance value, and you can straight away by looking onto the okay its physical structure. Okay, you can tell what the value of the resistor. Then how it is possible? Okay, let us see what the procedure will be given here. Okay, I hope you can see the resistor. Okay, we call as a color band. Okay, it is on the body of the like a resistor. We have a color band. Okay, each color indicate with the one value. Okay, usually there are like 3 bands will be given here. Okay, totally you can have 5 bands. Okay, initially we will be concentrating on the 3 bands. Okay. I hope you can see in the left side the first column we call it a band meaning. Okay, band meaning here nothing but a color of the band. Which color? It will start from the silver, gold. Okay, black, brown, red, orange, yellow, green, blue, violet, gray, and white. Okay. Initially, we'll at the moment we will be keep it aside for the silver and the gold. Okay, I'll cover it. Okay. Now the first color is a black. If it is a black, okay, it is a 0. The value of the black is 0. Okay. If it is a brown, it is a 1. Red, it is a 2. Orange 3, yellow 4, green 5, blue 6, violet 7, gray 8, and white 9. Okay. Okay. Now this is the color coding. Okay, will be mentioned with the corresponding values. Okay. Now I hope you can see there is like a first band, second band, third band, each having the same color. Okay, black in the sense 0. Brown. B.B. Roy. Okay, B.B. Roy, Great Britain, very good wife. Okay, by using. Okay, if you're not understanding this one, B.B. Roy. Okay, B.B. Roy. Okay, good wife, Great Britain. Very good wife in Great Britain. Okay. Now, okay, there is left to you how I'll be mentioning this one. Okay. Now, I hope you can see 0, 1, 2, 3, 4, 5, 6, 7 up to 9. The value of the white is 9. Okay. Now, I'll come to the silver and the gold. They indicate a tolerance. How much the tolerance? Okay. Just now in the previous way, I told the resistance tolerance plus or minus is acceptable. Okay. How much percentage is acceptable? Those are indicated with the silver. Now silver, okay, the tolerance of a silver, okay, look at this one. Okay, there is a plus or plus or minus 10% is acceptable if it is a silver. If it is a gold plus or minus 5% is acceptable. Okay, and I hope you understood this one. Okay, silver, gold and the black. Okay, now usually on your register there are like a four lines, 4 to 5 lines. Sometimes there are the 3 lines also. Okay, I hope I'll come to the band of this one. Okay, now look at the physical structure of the register. Okay, now when you observe, okay, you start from the like a left to right, from the screen side. Okay, this way, this from this side. Okay, you go from this one. Okay, now the very first circle line. Okay, which color you can see? It is nothing but a red. Okay, what is the value of a red here? 2. It is mentioned as a 2. I hope you can see. Okay, it's a 2 because in the below I mentioned red will be 2. Okay, next go for the next circle. Okay, on the register, which color you can see? Again it's a red. You mark it as a 2. 2 2. Just write a value 2 2. Okay, the next circle. Okay, it's a black. What is the value of a black here? 0. 2 2 0. Okay, now you come to the column here in this way, in this fashion. Okay, I completed with 3 1 2 and 3. 3 circles are over. The fourth circle indicate a number of zeros. Okay, now what the number of zeros? Okay, now when it is a number of zeros will be given here. Okay, now I hope you understood this one. There's a first circle is a red, second circle is also red, third circle is a black. 2 2 0. What is the fourth one? Okay, it is a red again. What is the value of red here? 2. Means 2 2. There are like 2 zeros to be mentioned. Means the value of the resistance is 2 2 0 0 0 0. Means the total value of the resistance is 22K. Hope you understood this one. Okay, 22,000 is a register value. Okay, will be mentioned. The value of the register is 22,000. Hope it is clear here. Okay, now I showed with like some, that's why like I told, sometimes okay, sometime on the register there is like only 3 lines. Okay, don't try to forcibly you insert a number of zeros. No, not like this. Okay, now for example here the fourth line is not there. Fourth line, according to me, the fourth line I say is a red. Fourth line. Okay, if it is not there, if it is not available. Okay, now what is the value of this register here? First you mentioned as a red, second it is a 2, the value will be 2, third is a black. If the fourth is not on the register, okay, you don't forcibly insert the zeros here. No, not like this. Okay, so what is the value here? 220 ohm. There is no number of zeros. Hope you understood this one. Okay, there is a next fifth round. It indicates a tolerance. The how much? What is mentioned here? Gold. Gold is nothing but what is a tolerance ratio is plus or minus 5% is acceptable. Of the 22 kilo, plus or 5% tolerance is acceptable. Hope the point is clear here. How you can see here. Okay, now assume that I removed 2 lines, 2 circle. Okay, there's like 2 circles. Okay, I'll remove. These circles will be removed. Okay, whatever the green are removed. Okay, I want to give the its resistance value. Okay, now what is the value? What is the first circle? Again the red. The second circle is a red. Okay, there are no any circles are there. Directly it will go to the a tolerance value. What is the tolerance value? Gold. Means what is the value of a register? What is the value of the register to be made? Okay, can be calculated 22 ohm. Then how much the tolerance is given here? Plus or minus 5% tolerance is acceptable. Hope you understood this one. Okay, this is how the process. There is a procedure. Okay, for calculation of a resistance. Okay, now I'll come to the example part. Okay, let me have a example. we'll calculate its values. Okay. Now, which color you can see? Okay, there are the how many? Okay, there is the first one. I can say there is the first one. Okay, as a second one, we'll calculate its values. Okay, how many circles are there on the body? There is like a first one. There is the 4 circles. Okay, 4 circle in the sense. Okay, I will mention here. Okay. Okay, now when there are like 4 circles are there. Okay, I'll come to this one. How many digits to be inserted here? First digit, 2 digit, 3 digit, 4th digit. Okay, that means though there is no indication of a 4th digit. Okay, now what is the value of a brown? Okay, value of the brown is 1. Okay, I write here 1. Okay, what is the value of a red? Okay, in the previously I mentioned 2. Okay, again there is a brown. Okay, okay, for the first value is 1. Okay, I can see 1. Okay, now there is a red is 2. Next is what? Brown and 1. Now I hope what is the value of the resistance is 121 ohm. Okay, what is the tolerance? Which will be the color will be mentioned here? There is a gold. Okay, the gold, the plus or minus how much here? 5%. Right. I hope you understood this one. Okay, the next. Okay, then the next okay, resistance. Okay, which are how many colors are there? The 4 colors will be available. Okay, now green, blue, okay, and orange. Okay, what is the value of green? Is a 5. Okay, what is the value of blue? 6. So second digit is a 6. Okay, next will be orange. What is the orange? 3. 5, 6, 3. Okay, now 5, 6, 3. Now it is not the gold. Now it is the silver. Okay, how much the tolerance is given here for the silver? It's plus or minus 10%. 563. Okay, means 563 plus or minus 10%. You can give it like this. Ohm. Okay, it's ohm. I hope you understood this, how the calculation. Okay, there is like a physical observation. You can calculate the resistance, or else, okay, there is the instrument is available. We call it a multimeter. By using a multimeter also you can calculate. Okay, in the multimeter we are having a points. We will insert it, and depends on like what value it can be expected. You make a range. Okay, make it into the corresponding range, and it will show the value of this. Okay, I hope you understood this one. Okay, how the resistance values to be calculated. Now these are the what the basic components, okay, are most used for the electronic devices, okay, instrumentation laboratory. Okay, not only for the given laboratory, it is throughout for the other circuits also. Okay, for the coming semester, or for the electronic purposes. Electronic purpose, if you want to make a connection and you want to try it for like any circuit operations, okay, these are the very much essential components are required. Okay. Now this is what in the today's laboratory we dealt with like basic components, how we will use, and the resistor. One of the component we have shown with the resistor. Okay, how the value of the resistor has to be calculated. Okay, and what are the components? Okay, where the basic component is required. Okay, in coming class we'll see many other components will be available. Okay, there's a functioning of the components. Then how do we handle? Okay, for the purpose of operations. Okay, thank you.